Hello dear students, welcome to EduCell. Today's session we will read heap data structure as well as how HEAPSORT will work, that we will discuss. Before that we should know uh, what is heap. Okay, so heap is a special data structure which is following almost complete binary tree or complete binary tree. Okay, you can find many books there it is written clearly almost complete binary tree or binary tree or complete binary tree. But in almost complete binary tree, we are following two certain rules. One is ordering, another is structuring. I'll write it now. Two properties. One is ordering, another is structuring or structure. So in ordering, there are two different types of insertion or deletion operations. Based on operations, I am writing it. Based on operation, we will write the direction. Okay. So operations like if insertion, so the direction should be left to right. This is the order that we will maintain for the first. You can say once we are entering one node at a single time. You can say for n number of times if we'll build the tree, it will take big of n. Why? Because one will take one time, so second will take again that constant time. Like if n number of indices are there to build a tree, it will take n time. I'll tell you how. Okay. To remove each element, we will follow a right to left as for the ordering purpose. Okay. For the structure, what we have to do, whenever we are creating the capacity, you can say maximum capacity, maximum capacity of nodes per level is 2 to the power level. You can say if level 4 maximum nodes will be 2 to the power 4, which is 16 nodes or children nodes or children could be possible within that level. Okay, we will discuss that. But before that, we should know heap is a special data structure, we can say, which is following the property of complete binary tree or almost complete binary tree. Why we are doing it? Because we need an ultimatum of sorting. Like recently we have read almost insertion sort, selection sort, and bubble sort, which is giving us n square time. We need to reduce that big of n square to some extent. At least that could be n log n, that could be n, that could be anything. That's why we are introducing heap to reduce that n square, which is given by the insertion sort, bubble sort, and selection sort. Up to this we read it. Now we are introducing heap for this reason only. We need to reduce the sorting. Why sorting is needed in general? If you can think, the data can be stored haphazardly, not an issue. But we need to find the data when we are actually finding. That time when we are finding, it is based on how you are storing. If you stored in a haphazard manner, you will start from one end to another end, or might be you will check it how you will be getting that item, finding it. Once you have found one item by any mean, then you have to find one element and you have to sort in ascending or descending order. That will take time. Like as you have already read in insertion sort, bubble sort, selection sort, there comparison will be done on a basis of a certain range. Like a bubble sort, two elements are being checking, like we have to check which one is greater. Like if you want to go for ascending order, always if anything is written like sorted, that doesn't mean that it will be ascending order always. Sometimes it would be said to be descending order. But western culture is all about like they're forcing to say those things which we should have to believe. No, this is not always correct. Sorting doesn't mean that ascending is always be the part of it. Might be you can follow descending is also part of it. Whenever the question will be there, sort it, we generally think ascending order, but this is not always correct. Sorting means we have to sort in a order. Might be ascending, might be descending. If condition will be used, which will take one constant time, you can say one time or constant time. So that is why we say might be ascending or descending. But if ordering is a part of it, then we should focus on the sorting. Okay. So sorting is more important than finding the element. Once we found it well, then only we can sort it well. If you cannot find it well, then definitely sorting will take time, because you are finding an element. It will take suppose n square. Then how do you go for a proper sorting or arrangement of those elements? It may take time. Okay. So now we'll switch to how one example that I'll give you, where the I have written this algorithm I kept from Corman book, which is a well-known book we should have to follow. In general, I can say you, most of the tutors nowadays are not following correct theme, like are not following where we are actually citing. So in general they are solving the problems which will be more easy for the students. But in my sense I should think if you'll follow the book, at least people will understand, because students are always coming for the video. The main reason is they are avoiding the book. If you introduce the book while teaching, that time it will be more easier for the student or more convenient for the student to understand it better. So now you can check, for an example, I'll say, suppose anyone will tell you create a heap, or might be a complete binary tree, or almost complete binary tree from an array. Okay, array. I'm just writing in that A. Okay, so where A is given to us. There are might be four indices. You can say one, two, three, four, and then that you can say 4, 2, 8, 6. Okay, suppose this is what it is given for creating the heap. I'm not saying it's a max heap min heap. Don't if you know it, don't think like that. Okay, like I'm not talking about max heap min heap. I'm just talking about to creation of heap. Like two properties it has to follow. Each level, I'm just before drawing it, we should discuss little bit of it. Each level, the maximum children or maximum capacity we have to think. Once it will be maximum, because we are going to insert one by one element. When we are taking one by one element, there are suppose four elements. If one is taking 1 second, so four will be 4 into 1 second, which is again 4 seconds, you can say. But that 4 is based on the index. If n will be the answer, so creating that heap for n number of elements will take big of n or theta of n. But big of n could be better approach for it. But this is not our target. Our target is we have to create a heap. Okay, that's why we need two property. One by one level we have to follow. One by one level we have to fill up the elements. Okay, so whenever we focus, as why I've written from 1 to 4, as per the book, as per the Corman book, which is written by the professors in MIT, they have written that they started the array index from 1 onwards. Okay, you can start from 0 onwards, not an issue. But if you can work with a 1 onwards, so this algorithm will work as per their convenience. Otherwise, if you started from 0, you need to place instead of I minus 1, because you are writing 0, 1, 2, 3. So because this is written as I, that time you can use I minus 1 by 2. So that will work. Okay, not an issue. Next solution, I'm just writing how to create the heap. Just creation of heap, not max heap, not min heap. Okay, so the first element is 4, and we know a level 0 will be the first. The root will be considered as level 0 of a node of a tree. Okay, level 0, I told you the maximum capacity of that level we have to judge always, because structure, then in first insert, then structure. Okay, or sometimes first structure then insert. Here we have to check 2 to the power 0, which is 1. So one node maximum could be possible for the first 0th level, or the first level you can say. Next, 2 will be inserted. I told you when we are going to insert, that will be from left to right manner. Okay, from left to right insertion could be done. Okay, so though from left to right insertion could be done, we can start from the left node, which is said to be 2. Okay, next you can write the index is not an issue. Next will be, I told you for level 1 we have to check the structure, then 2 to the power 1, the maximum children it has to keep is 2. Okay, so right now we have only one you can say element or one node. Here what we have to do now, we have to insert 8. Okay, we are just creating heap, we are not focusing on main heap or max heap. Okay, node 3. Now we have to check whether the level is filled or not. Yes, of course, two children could be possible or maximum capacity is this. That's why we have to stop. Next, 6 is given as an input. Though we have to follow the properties, first is ordering. Ordering insertion is left to right. So this one will be filled. Okay. So here we have stopped. This is how we have created the heap. Next is Heapify, the concept of Heapify. The concept of Heapify will exactly represent the exchange of or exchange between two nodes. Exchange between two nodes is said to be Heapify. Because within the heap, we are doing the property. That's why it is called as or considered as Heapify. Which type of Heapify you are going to do? If you are doing max heap, I'm writing here. If max heap, so in this case, the parent node should be greater than equal to child if you are going for the max heap. If you are going for the mean heap, okay, here your target should be child should be greater than equal to parent. Okay, so just little bit opposite to the max heap. For doing the max heapify, sorry, for creating or building the max heap, we need max heapify. Means we are actually changing the nodes. Same for creation of mean heap, where child will be the greater than the parent or greater than equal to the parent. That time what we have to do, we have to use mean heapify. Okay. So here A represents array, as we started from the array. So that's why we are representing that. And I stands for the index. From this example, I should discuss. From here, uh, nobody can say it's a max heap or a min heap. Why? Because 4 is less than 8 but greater than 2, but here 6 is uh, greater than 2. So if you say it's a mean heap, that could be correct for mean heap, but here when we consider, okay, it's not mean heap. Why? Because 2 is less than 4. That's why we cannot say it's a mean heap now. So our target is the total tree should be having same property, should follow the same property, either mean heap or max heap. Subtree is not a part of it. Subtree we have to consider, but subtree is just a subset of it. The whole tree should follow property. Then only we should follow either max heapify or min heapify. Before that, we should know how it will run. So it has to follow certain steps. Before that, we should run if question will arise or if question will be there. So how we'll solve. So here, suppose you can say mean heapify we will use mean heapify. Mean though it's written as max heapify, better we'll start with mean heapify, which will clarify our doubt. The same program I'll be running, but I just written it this way. And in the book you can check certain things be written like this. Okay, I want to focus here only, and I'll exchange everything. As per this, the 2 is a part of index. Okay, A is the array, and we have to run this. Okay, when we have to run this, We have to check whether 2 is less than the child node or not. First, we have to focus in this subtree. Okay, we found yes, of course, it is smaller than this. Okay, next 4 will be written there, 2, 6, here it is 8. First, the lower version will be checked, no need to change. This is step 1 because the parent node is less than equal to the children node. Then in step 2, we have to check it will be exchanged. Why? Because the parent is greater than the child or the children nodes present over here. If there are 1 and 2 both are there, so the lowest to lowest will be exchanged. Here 8 and 2 is written, so 2 and 4 will be exchanged. Why? Because the less will be on the top. The more less, the more exchange priority will be given. So once we exchange, so 4 will be given as the priority there. Next 6. So here we can say we have done with the mean heap now. This is mean heap. Okay. So this is a mean heap. I'll clearly writing it mean heap. Okay. So in this way we have created the mean heap, and to convert in array you can say mean heap array will be 1, 2, 3, 4. Now we have changed the indices. 4, 2 will be written, then 4, then 8, then 6. This is the array version of mean heap. Okay, array version of mean heap. But this is not always being correct. Sometimes you may get mean heap will be in an ascending order, but this is not always correct. Okay, so mean heap will not be ascending order always. Sometimes based on the array indices, it will be resized. Okay, from tree or from you can say from heap to array we have changed it. Okay, I have segregated now. So, what is the time complexity of Maxipify then? Though we are actually running, I'll change this color. Though we will be focusing on the header part. First of all, we have to check the L which is left. Left this function is calling for one time, so it will take big of 1. Okay. Now the right we have to check. It will take big of 1, and here if condition is written, if condition is running for one time, either yes no or no. So this is within the if condition, again it is running for one time, else part is also running for one time. Why? Because either or. Okay, for that reason here we go of 1. Here this is written within the for loop, we go of 1. If condition is written, again we go of 1. Here it will be exchanging with the largest one. Wherever we will get the largest, we will exchange that. Okay, but now when we focus here in this case maxipify, we will do the maxipify. Okay, so when we are actually running that maxipify, our main target is we are focusing on the array indices and the array with the indices. Okay, here up to this we are getting 1, but this is for one element only. Here we actually called this maxipify function. Better I'll change the color. I'll say the function, due to this function we cannot say it is big of 1. Up to this it is big of 1. We have to complete it. We have to again this is index, sorry, this is array and this is the index. Largest will be part of index. We have to then re-verify and re-verify. When we are actually re-verifying the things, we are focusing on the height. This is focused in the height, height of the tree, height of heap. The height of heap is, you can say, I'm changing the color. The height of the heap will be big of h, sometimes it is written, or else you can say it is big of log n, log n base 2. Why base 2? Because binary, due to binary it is base 2. Okay, so log n base 2 is a correct answer for height of the heap. This function will be called for देखो यहाँ पे we have to follow this order. Okay, up to this we have to follow. Once we have found then we have exchanged it. So exchange will be possible based on the height of the tree, a level of the tree, you can say. Okay, that's why the time complexity is taking, whether you are focusing on a max heap or min heap, for both the time complexity would be log of n, where log will be base to n. Okay, so I hope it is understood. Next is heap sort. So up to this we have completed like how to create and what is the time complexity of max heap or min heap. Next is to build the heap. We discussed recently, like we have to focus each element will be based on the ordering purposes. If one element we are keeping on a basis, in that case you can say it is taking big of n time. Okay, so that is how you can complete the ordering point of view, the ordering part of it. You can check in the book; it is clearly being mentioned how they are getting the build heap as big of n. It is clearly being mentioned in mathematical formula. So better before that we should discuss how HEAPSORT is running as per the book. Okay, we will be taking the same example. Once we have completed with the example, then we will discuss the time complexity in HEAPSORT. Okay, so I'll write the same question. HEAPSORT, the below array. Array is written as four indices are there. Here 4, 2, 8, 6. 4, 2, 8 and 6. Remember the steps which I am following. I am following the Corman step. Okay. Now we have to first build what we have to do here, build max shape. First we have to build max shape. Okay. This is the first step. Build a max heap means first we have to create, either you can build the heap, then you go for the heapify. Building of heap, one element that you are keeping first, which is n. Then when you are going for the heapify, it will take big log n. So the whole total, the time complexity will big of n plus log n using heapify method, which is big of n. Or else, like each element whenever you are keeping, that time you are actually swapping the same time. Okay, which will be big of n. As per the book, they have actually solved it. So instead of saying it's big of n log n, they said properly how in mathematically they are getting n, because this is not the correct time complexity they are getting as n log n for building the heap. That's why they said it how they are getting n. But as per me, what I said, whenever you are getting this, first you create the heap. Whenever you're creating the heap, it will take for n number of elements, it will take big of n. Then for heapify, it will take again log n. So n plus log n is the greater will be written, so big of n. As for the book, it is clearly also mentioned how n is written. Okay. Now we will be going for the creation of heap first. Now I'm just writing it. 2, next 8. Small example will be better to understand. That's why I have taken. If time will permit, I'll focusing on the biggest problems or big questions, where we will be discussing only, or we will be solving the questions only, rather than discussing the theoretical part of it. First, theoretical part should be completely understood by you. Okay. So here 1, 2, 3, 4 I have written. So this is not max shape. So we have to convert it to max shape first. Max shape, because as per the heap sort written in the book, we have to completely convert the heap to max heap. Okay, when we are completely moving to max heap, only this thing will happen. Okay, either you can start from the bottom as per this max heap, it is clearly being mentioned. So we will start here, you can say for the max heap, when we completely converting, like here the changes could be possibly done is like the this will be converted, this will be changed its location to, because the parent here is 2 and the child is 6, so they will be swapped first. Step 1, here what we have to do is 4, next 6, next 8, next 2. Okay, so then step 2, we can, like, here child is smaller than the parent is smaller than the child, and we have to go for the maxip. Though we have to go for the maxip, in second step, in second step we have to exchange with the largest one. Though we know 6 is the largest than 4, but as compared to 6, 8 is more than the bigger number, bigger value which we got. That's why 8 could be written in the place of 4, and 4 will be shifted to 8, then 6, then 2. This is the max if we got. Okay, max if. Next, what it says, for a length which is the maximum array length to 2, means you can say the array length is the array length down to 2. Okay, so you can say the array length is 1, 2, 3, 4. Okay, so as per this, array length to 2 means maximum from leaf to leaf or last level to second last level, second level you can say. Okay, up to second level we have to run it, we have to run the for loop. Within that, we are exactly we are going to change. Within that, we have to change with the first node. The first node is said to be a of 1, which is this one, will be exchanged with the last node, that is written as I means we started from the array length, then it will be changing as heap size equal to heap size minus 1, means the heap size will be decreasing to minus 1. 1 1 we are actually removing. I told you from the beginning, when we remove, that will be from right to left. Okay, that you we will be discussing. Okay, don't worry. Now, as per the approach done by the hip shot, we will run. But the step 1 says, for hip shot, what we have to do, the step 1 hip shot, we have to exchange. Here it is written, we will run a for loop, and we have to exchange the 1, the first, which is root element. This is our root element, root node, with the last node. Why? Because if the last node is getting deleted, there will not be any problem in the structure, because left to right should be filled. If right will be discarded, no such issues we will be finding. Okay, suppose you can see, if a b is connected, so here suppose d is connected and e is connected, this is how we can say it's a heap. Okay, so if you are removing e and you keep as it is, so here is the tree might be created, but, or you can say here is a heap, we can say. Why? Because left is connected na, here right is not there. So when right is not there, we can say not an issue for creation of heap. Okay, so heap could be possible, or heap could be said if you can say, if suppose this thing happened and we are removing, means definitely we said the element will be left, should not be deleted first. If you have two elements, if you have two nodes, one is left, another is right, right should be deleted, then only left will be deleted. Okay, so that's why I told you from the ordering, the first one, I recommend you the operations, when you are doing remove, the right will be removed first and then the left. That is what you are following, the ordering part, and structure will be maintained as it is. Okay, so this is what we discussed. Now we have to follow the heap size. When we say the heap size means we are indirectly discussing the array length, or a length. Array length will be decreased by 1, means Decrease by ones means we are removing the last node indirectly. Clear na? We're removing the last node. Array length minus 1 heap size that previously we declared. Here the small code is written in the book. Some points are written somewhere, but we have to find it. Heap size is equivalent to the array length. It has to be written the beginning of it, but somewhere it is written before heap sort. It has written there heap size equal to array length. Okay, so that's why I may not able to write here, so that's why I discussed here now. And once it is done, so we will run the max cpify with the element like the whole array, and here we are keeping this as index for us. Then everything will be sorted as usual. Okay, it will take, like recently we have studied the time complexity. We are not going to take the time complexity in actions here. We are actually reading how it will run. Okay, now I have to run this exchange one. Once we go for the exchange, I'm just changing the color now. Okay, for exchanging I'm using blue color. Okay, now it will exchange. Once max heap is done, it will be exchanged with the last node, with the root node. Okay, now it is done. The step one we have to write 2 will be there, 6, then 4, then 8. Okay, now we restart it. Once we reached, so we exchanged, then heap size equal to heap size minus 1 means array length equal to array length minus 1. So step 2 says we need to remove. Step 2 means remove. Okay, so once we are removing, as per the book it is clearly mentioned, we keep that element, we will not touch that element. Okay, because it is written on the left part, we keep as it is, color it as it is deleted. Okay, so I'm just writing it is deleted now. Once it is deleted, so we have to write 8 as it is. Take 8 is deleted now. I colored it that it deleted or removed. Now this is step 1.2. Better we should write, because it's the fourth step we have done. Next heap sort, step 2, we have to go for the max cpify. For the max cpify, the exchange will be done. Okay, for this exchange we can convert into max cpify, then 2, because 4 and 6 are two bigger numbers. Out of the biggest is 6, so we will switch the biggest number with the number which is 2. Now 4 and 8 as it is, keep as it is, do not touch it. Now step 2.2 says we will exchange with the last node. Here 1, 2, 3, 4. Now connected last node is 3. Connected last nodes we will be discussing. We are not going to discuss any other numbers. We are now focusing on the, now I think it's openly understood. These are the you can say 8. This is 8. We have deleted. Okay. Now we have to exchange with the, for exchanging we are using this color. Here I am writing exchange with the first node with the last node. It is written first node with the last node. Okay, now you focus here. 4 will be written there, 2 will be written as it is, 8 will be written as the, 6 will be written as the last, 8 will be written then. Okay, so here I am just writing the indices, because indices are more important to display these elements now. So here in step 2.2 we have to remove that we discussed recently. Okay, so here it has already been deleted and removed. Now 6 we have to remove, because Once exchange has been done, as per this, exchange done, next we have to remove it. Once we have to remove it, now we can keep as it is. Now there are two different nodes we have. Okay. Now we will interchange because max shape we have to create. For max shape, uh, it has already been in max shape. Why? Because the parent is there above the child, so no need to change it. It's already in a max shape. Now we have to say it's step 3. In step 3, what we have to do, we have to go for exchange. Okay. Exchange. As for the exchange, you can write 2 on the above, then 4 connected, 6 and 8. Okay. Now I have converted. 1, 2, 3, 4. Next, we have to remove it. Step 3.2 says once you have done the exchange, you have to remove that one. Here also remove. Okay. Once you have done with the max it, then you exchange. Then you remove. Okay. Once you have removed it, so it will be look like 2 and the above, 4, then 6, then 8. Once it is removed, you write 1, 2, 3, 4, and you highlight the deleted one. 8 first it deleted, next deleted is 6, next is 4, and after running 4 point, after running its 4 point step 4, only one element is there, so no need to write it. The same thing you have to write after running for 4.1. So it's step 1 2.1, it's step 3.1, 4.1. You can remove it, so the correct answer will be 2, 4, 6, then 8. All have been deleted. Now after that you have to follow the array. That array is your heap sort. Okay, so I'm just writing that one. This is what a heap sort is. 1, 2, 3, 4. Here 1, 2, 3, 4. I have to color it, means highlight it. So everything has already been deleted now. Remove, I colored like this. Okay, we have removed it. Now, okay, the elements we will write as per the deletion. Then only it will be correct heap sort. 4, 6, 8, which is heap sort. SORT. Clear now? So whenever you have deleted or removed one element, then you have to convert that into array, list of array, or the list of array elements. That list of array elements will be your heap sort. So the node we will be discussing now, but before that we should know what is the time complexity. Before that I should change the color of it. Now to build it, the time complexity it will take is big of n, how that we discussed. For one element it will take one constant time, so n elements it will take big of n, or else as per the book you can check. So a build heap program is written, or algorithm is there, where it is written as n log n, which is not properly being time complexity, which is not tightly bound. It is written there. So as per the mathematical formula, so they got it as big of n. In that case, n by 2 to the power h, it was written n by 2 to the power h as big of n to the power h. So when they went for the solution, they got n as the correct answer. Okay. Next, for loop is running for length up to 2 means last two 2 means is n minus 1 times it is running. Okay, for n minus 1 time it is running, within that exchanging it, exchange is running for one time, and heap size is running for one time because each statement will run for one time. But here the time complexity of max heap is log n. So they are within the for loop, n is getting multiplied. Okay, because within the for loop they are actually running, the for loop is running for n minus 1 y from last to the not root but the before one root. So total, if n is the number of nodes, one node we are actually removing, that's why it is n minus 1. Okay, so the total time complexity will be adding of all the time complexities. Total time complexity is equal to big of n plus n plus minus 1 times we are writing. Better you can run as big of n also, not an issue, because for loop is written within that. The elements we have actually written for one time, which is you can combine everything as big of n. Okay, and then you write big of n log n. Why? Because hippify is log n time it is running max hippify. Okay, or mean hippify, because it's based on the height, and though it is within a for loop, it is n log n. So in general you can say we have 2n plus big of n log n. That, as per the asymptotical notation, maximum is this one. So that's why time complexity for heap short time complexity is equal to big of n log n. If in doubt, how n log n, put the value n as 4, suppose यहाँ पे 4 डाल दो, तो big of 2n will be n के जगह 4 है, ठीक है, तो यहाँ पे 8 हो जाएगा. big O के जगह n के जगह 4 था, n के जगह 4 डाल दो, तो you'll get the answer n log 4 बेस 2, यहाँ पे बेस 2 है, ठीक है. तो बेस 2 जब है तो याद रखो log 2 to the power 2 2, so 2 इस साइड आएगा, log 2 1. If I want to simplify, I can write in this way, because 2 was square, the 2 will be coming in front. Next 4. Okay, big O, you just write it for a timing. This is 1, so now you will get 4 into 8, 4 into 2, which is big of 8. Big of 8, after getting this, here is also 8. This is now equal. If you take the value as 8, this time the value could be, suppose n is 8 now, n is 8, this time it is 16. When you are taking n as 8 now, okay, n is 8 means 2 to the power 3, if 3, so here we can come with this 3. Okay, here the value of n is now 8, 8 and 8, as to write this one. So when 2 to the power 3 we have written, 3 will be coming in front when it is done. So log 2 base 2 is 1. So 8 into 3 is 24. Okay, big of 24. So that we know 24 is greater than 16. Yes or no? That is why we are writing n log n is the maximum time complexity. That is why we are writing. Okay, so this is just for example. I am just taking you taking to give you the proper idea about the complexity. Do not worry if certain problems, certain hurdles are coming to find the which one is greater. You put the value of n, because n is variable. That's why we are thinking, though n is written, it could be anything. So why not you put the value that we have discussed in counter example, that indirect proof. Take any example, take any random values, go for it. You are checking the correctness of it. Why you are worried about? Okay, so notes, special note, remember. Okay, what we have to do always when you are doing for the hip shot. Okay, if max it, and you are following the property of hip shot, Max heap means increasing order. You will get in increasing order. You can check. Here we have heap shot. We have converted to max heap. Then we run the heap shot property. When we run the heap shot property, we get 2, 4, 6, 8. 2, 4, 6, 8 is ascending order, or you can say increasing order. Ascending order or increasing order you will get. Next, if mean heap, okay, if mean heap, you are running the heap shot, you will get decreasing order or descending order. Okay, you always remember. These are the thing which we got as per the note maxip and minip. Why we are using maxip? Because we thought for a time being the sorting means increasing order, but this is not always correct. As for the book, they started with the maxip because of to get the increasing order or a ascending order. Okay, this is how we completed the heap shot, and heap shot is taking big of n log n, which is less than n square, which you read from insertion sort, bubble sort, and also selection sort. Okay, this is how you are getting using heap data structure. Okay, this is the reason to read the heap. So I hope this is understood by you. If any doubt, you can comment below. And thank you for watching. Have a good day.